Is it quantum revolution? A new era of computing? Quantum computing is a groundbreaking technology that combines computer science and quantum physics. Unlike regular computers, which process information using simple zeros and ones, quantum computers use special particles that can exist in multiple states at once. This allows them to tackle complex problems much faster than traditional machines. Quantum computing isn't about just making computer faster. It's about solving challenges that were previously impossible using the strange but well-proven rules of quantum mechanics. Quantum computer is a new kind of computer that works in a completely different way. It uses qubits. It should be 0 and 1 in the same time. Thanks to two quantum effects, superposition and entanglement, quantum computers can perform calculations that would take regular computers an enormous amount of time. This could lead to breakthrough in science, medicine, and technology.
Quantum computers utilize specific quantum phenomena to speed up their calculations. Two most important ones are superposition and entanglement. Superposition is a quantum principle that allows a particle to exist in multiple states simultaneously until an observation collapses it into one definite state. A classical system with similar behavior to a quantum particle could be a coin toss. The quantum state of the coin corresponds to the situation when it keeps spinning on the table, and to the human eye, both states merge into a single image. Only after the coin lands on the table, the chance of getting heads or tails is equal to 50%. Entanglement is a term used to describe the intrinsic dependence between variables. When two particles are entangled, knowing the state of one immediately gives you information about the state of the other. To illustrate this, we can use a simultaneous toss of two coins. Although in the classical world, we consider each toss separately, in the quantum world, the result of measuring heads on one coin automatically determines that the result of the second experiment will be heads as well. Since quantum computers are an emergent technology, research on how to build those devices most efficiently is still ongoing. Today, there are many types of quantum devices and their various hardware implementations. The most general one is a universal quantum computer. It is a quantum computer that is able to perform any quantum algorithm. It uses qubits and a set of universal quantum gates to perform operations. This type of quantum computer can have different hardware implementations. Among others, we can name superconducting quantum computers, which are fast and have the biggest number of qubits but require extreme cryogenic cooling, ion-trapped quantum computers, which have less qubits but have a higher gate fidelity, and photonic quantum computers, which are very fast and do not require cooling, but have high errors and a small number of qubits. Other than that, there are other types of non-universal quantum computers, which are machines that utilize some quantum phenomena to perform some kind of computations. Some computing paradigms include quantum annealing and boson sampling.
The main difference between classical computing and quantum computing is that instead of using bits, we use qubits, which can be in superposition, and they also can be entangled with other qubits. A qubit can be physically, for example, two energy levels of an ion trapped in an electromagnetic field, and we can perform quantum operations on that ion by shining specific laser light on it. Also, those operations can symbolically be represented as quantum gates, and a sequence of quantum gates is called a quantum circuit. Quantum circuits are very similar to classical logic circuits, but the main difference is that the lines represent evolution of quantum states over time, so loops in those circuits aren't allowed, and also the number of inputs to the gates are the same as the number of outputs from the gates.
Quantum computers sounds both futuristic and expensive, right? But did you know that you can simulate quantum computer or even run on a real device even from your home? You don't need the PhD in physics to actually perform quantum experiments. There are many tools from which I decided to show you two. IBM Quantum Composer. This is a user-friendly drag-and-drop interface where you can take any quantum gate, apply it on circuit, and then either run in simulation or decide to run on real device. And there is also Qiskit if you prefer coding in Python programming language. Qiskit is open source Python library where you can create, execute, or run in cloud any quantum circuit, even from the lower pulse level. You can here build circuits, perform any experiments. There are plenty of tools that will help you with that, and currently Qiskit is the most popular and the most beloved by the community.
Today we live in the so-called noisy intermediate scale quantum era, where quantum computers are not very powerful. They are very prone to noise and errors, and that noise sometimes can lead to the situation where quantum gates do not perform the operations in a way that we want them. And the qubits sometimes change their state unexpectedly. But still, quantum computing engineers are constantly working to improve the hardware. At the same time, quantum software engineers are developing new algorithms and searching for new application areas where the technology could be used when the hardware is ready. And that include, for example, quantum artificial intelligence, but also quantum chemistry and some more complex simulations and many areas in optimization, like finance or scheduling. And one important field here is cybersecurity, where quantum information could make the internet more secure.
Quantum computing is advancing incredibly fast, with new breakthroughs and discovery happening each month. We cannot exactly predict what will happen in the future, but what we can tell is that it's going to be huge. Many major companies like Google, IBM or Microsoft are fighting for the spot of the best quantum computer. It will probably take the whole room in some supercomputing center. It will be huge, incredibly powerful, and require some cryogenic cooling or vacuum. But there are many other companies that are fighting for other spot of the smallest and most accessible quantum chip. For example, this Samsung Galaxy Quantum is a phone that has quantum chip in it. It's used mostly for generating random numbers, but it's already today, and it's only as a prototype. We also expect quantum computing to play major roles in such fields as medicine, with help of new drug discovery, or in logistics with help solving algorithms that were so complex that it would not run on classical computers effectively.
The quantum revolution is coming. Quantum computing is likely to work alongside classical computing. As the technology matures, we may see hybrid systems that leverage both quantum and classical computing for different tasks, maximizing their respective strengths. Currently, quantum computing is in the experimental and development stage, with researchers focusing on building stable quantum bits, qubits, and demonstrating quantum advantage in limited cases. Despite its potential, its widespread practical applications are likely years away. Wherever we need a solution to a problem based on probability, a properly constructed quantum algorithm will be significantly faster than a classical computer. What's more, the energy efficiency of a quantum computer compared to a supercomputer system will be incomparable. A quantum installation will consume as much energy as an ordinary electric kettle.